First thing we'll do is rewrite this using a limit of sums, and we'll just use the generic version for now. The limit as n approaches infinity of the sum from I equals 1 to n of f of xi delta x. First thing we want to do is a little side work to figure out what delta x is. The formula for delta x is b minus a over n. In this case, b is 1 and a is negative 2. So delta x is 3 over n. And then x sub I formula is a plus I delta x. So we have negative 2 plus 3 over n I. Now rewriting our limit, we have the limit as n approaches infinity of the sum I equals 1 to n of 2 is coming from the function. We're going to replace x with negative 2 plus 3 over n I, and then delta x we found to be 3 over n. Next, we'll simplify this a little bit. Limit as n approaches infinity. Since 2 on the outside and 3 over n on the outside do not contain an I, they're just factors, we can pull them out of the limit. So we have 6 over n, limit I equals 1 to n of negative 2 plus 3 over n I. The next thing we'll do is rewrite the sum as two separate sums. So we have the sum I equals 1 to n of negative 2 plus the sum from 1 to n of 3 over n I. Continuing to simplify this. In our first sum, we can pull out the negative 2. Pull it out of the sum, leaving us with the sum of 1. And then in the next sum, we'll pull out the 3 over n, leaving us with the sum of I. We now have the limit as n approaches infinity, 6 over n times negative 2. The sum of 1 will just become n. Then we have plus 3 over n times the sum of I is n times n plus 1 all over 2. Up next, we will simplify some more. Limit as n approaches infinity, 6 over n, negative 2n, and see the n's will reduce. We can distribute the 3 and separate these fractions. We get 3n over 2 plus 3 over 2. Now distributing the 6 over n, we have the limit as n approaches infinity of negative 12 plus 9 plus 9 over n. And now we can evaluate the limit. N is going to infinity, so this fraction is approaching 0. That means we have negative 12 plus 9, which is negative 3.